Dan Meyer is a maths educator from the States, and he in this clip that I'm going to show you, a short clip taken from a longer TED talk, he's talking about this maths question where it says, well, there's a picture with the ski lift and the questions are, what's the vertical change from A to B, from B to C, from C to D? What's the horizontal change from A to B, from B to C, and so on. Find the ratio of the vertical change, which section is the steepest. It's the perimeter worksheet that we did, right? It's the, go through these motions. Let's see. And that idea that Dan Meyer's got there, that, there are all these items out there, but all they do is they pave this smooth, straight path from the question, from the compelling question to the answer to that question. And we congratulate our students for stepping over the cracks in the way. That's that kind of limited industrial model of education. We've now got a new verb in our office, and it's Dan Meyering. And the reason why we talk about Dan Meyering is because there's not that many great resources out there to support this kind of development of thinking at the moment. And even if there was, we've already bought our resources. Our schools are full of resources. We've got our textbooks, we've got our work, we've got our resources that we're working out of. And so with our work, what we've been thinking about is, well, how do we take those and Dan Meyer them? How do we take those existing resources that we've got and impose upon them this strategic intent of the curriculum? How do we make sure that the essence of our learning area comes through our existing resources? Because obviously in the first example that Dan showed, do this and then do this and do this, that's not it. But he's used the same stimulus item to say, which section's the steepest? Go on, prove it. Show me. Find out. And actively taught. So instead of, the teacher being the person who puts the question down, who tells you the stuff, puts the question down in front of you, and then you go through the question, that now the question becomes the way in which he can do that active teaching. That the teacher, that Dan in this case, can get in and actually be an active participant in scaffolding the student's thinking, rather than being, in transmission mode. So, for example, we took a question that was written on a piece of paper and turned it into just a photograph. And so what we've got is a workman here, and he's got this long plank of wood on his shoulder. And what he's going to do is he's got to walk down this corridor, this newly painted corridor in this new building that's just been built. And when he gets to the end of the corridor, if you look down the corridor, you can see that the corridor does a 90-degree turn at the end. He doesn't want to scratch the paintwork. He doesn't want to mess things up. Can he get round the corner? Yes or no? Okay. So how can he? All right, so he's going to stand it up. Okay, so now let's change it. Let's change it to a piece of glass. So now what we've got is a long piece of glass. So it's a big piece of glass. We've got two guys who are holding it and are walking down the corridor, and they've got to get round the corner with a piece of glass. Can they get round the corner? Break it. I've got, okay. That's a way. And of course, I've heard it depends. Yeah, and of course it depends. So so now we've got to ask some questions about what's going on. We've got to say, we might ask some questions about, of course, how long it is. We might ask some questions about how wide the corridor is. But how are we going to approach it? How are we going to do it? The way that this was originally written required the students to draw a particular diagram, because that diagram had been half drawn for them. Instead of going, there's a problem here, what do you think? Use your maths to engage with it. It essentially structured the students to do it this way. But of course now we can imagine how we could draw a plan view. We could definitely do that. And we could, draw it, and we could write on, I could tell you how long the piece of glass or the plank is, I could tell you how wide the corridor is. And then I might ask you to do it generally. So what's the relationship between the piece of glass and the plank of wood, the piece of glass in the corner? What's the relationship between them in order to get around the corner? But you know what? I could just make it, right? We could get some boxes. I could put one box inside another. So if I've got a box and a right angle, and I put another box inside it, so I've created a corridor. Now I can get some pop sticks or whatever, pencils, and try and get them and make them longer and shorter, and try and get them around the corner. I can come at it from all kinds of different ways that the question never envisaged. But the compelling question, and it's not really a compelling question, but the compelling question, the thing that I want to give ownership to the students is, what do you think? Can you do it? How would we do it? How would we? And instead of saying, we're going to do it like this, I'm going to draw it like this, and I'm going to move on, I'm going to do this, I'm going to do this. We're not going to step over the small cracks in the way. We want them to get there, and we want them to get to the point where they can work it out for a specific example. And we want them to get to the point where they can work it out generally. But we don't have to rush to the bullet, rush to the middle and say, do it this way. This is the only way of doing it. We can come at that understanding in lots of different ways. And that Dan Meyering, that formulation of the problem, formulation of the way in which we're going to solve this problem, really comes out of the essence of the subject. Okay. And again, I would say that it gives us, again, with that work that you've been doing around so much work around the formative assessment, this is another fantastic opportunity for that formative assessment, because now, with the essence in mind, with the strategic intent of the curriculum in mind, with the students going through these processes and we're scaffolding in it and we're actively part of the conversation. Dan talked about the conversation, the maths serving the conversation, not the conversation serving the maths. We weren't going through the motions of maths and talking about how we would do that. We had this conversation, we were doing the reasoning and the problem solving and bringing our understanding and fluency to bear on the problem. And so now the kinds of feedback that we can give to the kids about their reasoning, about their problem solving, is perhaps more sophisticated than it might otherwise be. I think I've just said that. That we, and that we can use it in assessment as well, because now we might be thinking about assessing against the proficiencies, the essence of the curriculum, rather than, can you get this answer right or wrong? Rather than, can you step over the small cracks? And I'm going to assess you on your ability to step over the small cracks. Now I'm going to assess you on your ability to actually engage with the compelling question and have a go at it. I'm not going to talk too much about this in detail. I know many of you will have seen me or other people talk about this before, this idea that there are, at least four pillars of learning. This idea that there are, a couple of pillars around knowledge and know-how. Kids need to know stuff, and in fact, let me just zoom in on one of these. Kids need to know stuff, in the knowledge, and again, you might have seen me show this before, but this idea that, if this is a NAPLAN question, which says, which shows a reflex angle? Somebody's got to tell you what a reflex angle is, right? You've got to be told that thing. The content knowledge is crucially important. And then, I'm just going to go back to the right place. Similarly with some of our procedural know-how, to be able to go through the process of a particular subject, to be able to, in maths, know that I've got to take this number from that number in order to get the answer. Somebody's got to really help you and tell you that, show you how to do that, and you've got to practice doing that. Kids need to know the times tables. There's no doubt about it, and they need to know the times tables automatically. They need to. If I say to you, "What's 3 5s?" You can't help it. Even if you wanted to stop 15 popping into your head, you couldn't have done it. It was there before you were even aware of it. But of course, that's not there for some kids, and that's an incredible barrier to future learning, not having that fluency at your fingertips. But one of the, let me just zoom out on that again. But one of the third pillars that we see is there's some stuff that really, even when the kids have got the knowledge and the know-how, that they still can't do. They can't often put it into action. And what's interesting about this is it's not instructable. You can't tell it. You can teach it, you can actively teach it, and the kids can definitely learn how to do it, but you can't tell it. Let me show you an example. Again, this is a well-worn example. This is a problem-solving NAPLAN question, a problem-solving question, year 7 question, and it's telling us that there's a square on the bottom with an equilateral triangle sitting on top and a square on the side of that, and there's a line that goes down the diagonal, and it's asking us to find out the size of the shaded angle. I looked at this and went, year 7? I don't know what to do. And I got over my initial panic and started to have a go at it. But for lots of our kids, they never get over that. They go, I haven't got a way into it. I don't know, look at all that stuff. But then those same kids, if you get hold of the hand and say, okay, so what's the angle in the corner of a square? 90, yeah. So what's half of that? 45, I can do that. What's the angle at the corner of an equilateral triangle? Say, 60, yeah, I know that. And what about along the straight line? Yeah, that's 180. Oh, yeah. So I'm going to take 180, subtract 45, and subtract 60 from that. and I'll get that back. Oh yeah, I can see it now. They've got the know-how, they've got the knowledge, they know the angles, they've got the know-how of, I'm going to the process, the procedure, I'm going to take that number and subtract these numbers from it. But they can't do it when they're just presented with the problem because they can't think through it. And so we see that there's this kind of massive issue for our students in terms of that, that third pillar of putting it all together. I'm jumping around a bit here, I know. Clearly, this doesn't come this doesn't come from better or more or louder instruction. More and more telling. You don't get better and better at being a problem solver through that. You might get better and better at that one problem. This is something that we've all said. Oh, but I've taught them that. I've told it to them, and they still can't put it into practice. Oh, it's very frustrating. And the one that I love the best, I know I'm jumping around still, is this one. This was a year 3 question from last year. And it says, Mrs. Collins, the formatting's messed up on that a bit, sorry. Mrs. Collins asks her students to do these things, so you might do it. Think of a number between 1 and 10. Halve it. Add the number that you started with. Multiply by 4 and divide by the number that you started with. Okay. So there's lots of steps in that. So just the number of steps puts our kids off, and lots of them will fall away. Even the kids who, some kids, and it's funny with the NAPLAN test because they don't like writing on the paper if it's not in the box, so they won't write down their answer at the end of every stage. Nationally, only 11% of our students could do this in year 3. The answer's 6, but we don't care. But what's interesting is there was a whole cohort of kids who got to the answer 6 and then got tripped up when they were asked, what answer should everyone get? I got 6. Don't know what everybody else got. So there's a big cohort of kids who could do the fluency stuff, could go through the motions, could hold it all in their head, got to the answer, and then fell over when they were asked, what should everyone get? And being able to deal with that cognitively and to be able to think that through. So we see this, and I'm not going to talk about this today, this fourth pillar, this view of yourself as a learner, that disposition that they talked about in adding it up. And so what we see is, kind of on the left-hand side, we've got these things that are instructable and should be instructed. And on the right-hand side, we've got these things that are learnable but are not instructable, are teachable but are not instructable. These are the kind of post-industrial things that Dirk van Dam was talking about. These are the things, this is the strategic intent of the Australian curriculum. This is the strategic intent of the early years learning framework. This is about us in Australia enacting that shift. And it's this shift, not to leave behind the columns on the left, not to leave behind the columns on the left, the instructable, but to take them and to make the most of them by developing the columns on the right as well. We see it in South Australia with our NAPLAN results, and we've talked about this before, and again, I'm not going to go into detail on this, that there's almost this kind of barrier where we're doing quite well in the middle, but then what happens is we've got these students who are kind of pressed up against this barrier, that we teach them and teach them and teach them, we instruct them, and they get closer and closer to this barrier, and then we instruct them some more and they get pressed up against it, we instruct them some more and they get pressed up against it, and we push harder and harder and harder, but they're not problem solvers, and they're not breaking through that barrier. They've got great fluency, they've got great know-how, but they're not taking that next step through. And I'm going to come back to NAPLAN in a second. And then again, this idea that if we look at it from a neuroscience point of view, when we're doing what people might call a learning cycle, a teaching cycle, demonstrate, practice, test, we need to do that sometimes. And when we're doing fluency, that might be, we might think about that being an appropriate thing to do. And when we look at what's going on in the brains of kids who are developing fluency only, we see this activity in their brains, but then they kind of reach the limit. You can go through this again and again and again and again, and the kids are not going to break through that barrier. They're pressed up against that barrier. When we look through the barrier at the students who are doing some of the problem solving, obviously this look at the activity of the student's brain is from a different technique. Quick thing to say, when you look at these pictures, left brain and right brain are the other way around. What you see as being on the left is actually the right-hand side of the brain. It's a radiological convention. So what we see is this student doing some maths problem solving. And what we see is that the same sorts of regions of the brain are active, these same regions, but now this frontal region of the brain has become active as well. It's different. This frontal region of the brain is part of the brain that's doing those stop and think skills that I'm sure you've heard me talk about before. Those organising your thoughts. That, okay, so I know this stuff, and here's the problem. How can I put it all together? That stuff is what's going on in these frontal regions of the brain. Breaking through that barrier from being instructed to actually being an active learner is about the difference between the environment. On the left there, we're scaffolding towards knowledge and procedures. Yeah, that's your left. And on the right, we're scaffolding towards that thinking, inferring, and problem solving. And it's different in the kids' brains when we're doing that. And so for me, the shorthand difference about breaking through this barrier, not either or, is that sometimes we're asking the question, what's the answer? And when we break through that barrier, what we're also asking the kids is, what do you think? So when we did the perimeter thing this morning, the worksheet was asking, what's the answer? And when we did the hands thing, I was asking you, what do you think? One way or another, I was asking you, what do you think? I was demanding of you, what do you think? When Dan Meyer showed his clip and how he Dan Meyered that task, what he was doing was, he was turning a task that asked, what do you think's the answer? No, what's the answer? No, what's the next answer? And what's the next answer? And what's the next answer? And what's the inescapable next answer? And what he did was, he ripped all of that out and he used the same stimulus material and said, what do you think? He turned the resources that we've already got and took them from the left-hand side, I keep doing it because of my left, on the left-hand side to the right-hand side. That he stopped, he used the same resource, but used it to ask the kids one way or another, what do you think? I think this is really important, and I think when we look at the NAPLAN, it really stands out. People will talk about how we've got to practice NAPLAN, and we've got to improve NAPLAN, and all those sorts of things. And how teaching to the test is terrible. Teaching to the test is terrible if the test is terrible. But if the test is testing, if our assessment is testing what we value, then it's not such a bad test. There's all kinds of things wrong with an NAPLAN test, the way that we do whole cohort testing, and you don't get your results back for 6 months, and the high stakes nature of the test, there's all kinds of things wrong with it. But there's some really powerful things about the actual quality of the items within the NAPLAN test. We've looked at lots and lots of results from NAPLAN. This is national results from last year, looking at the Year 7 paper, the calculator paper. And what I've done is I've just gone through the paper, and I've looked and said, which of these questions is fluency only? Which of these questions only demand some knowledge and know-how? And I've coloured those in red. And then I've said, which of these questions are fluency plus? Yes, require some fluency, some knowledge and know-how, but are actually bringing in some problem solving. Are actually bringing in, more than that. They're actually demanding of the kids that they're getting into some of those other proficiencies. And I've coloured those in blue. And the ones I couldn't decide on, I've coloured in purple. So the purple ones are the ones where there was a bit of understanding really starting to come out. The understanding almost kind of being the bridge between the fluency and the problem solving and the understanding. And time again when you do this, what you see is the same sort of pattern. That exactly as you'd expect, there is a greater proportion of students so what we're seeing here is the paper going from question 1 on the left-hand side through to question 33 on the right-hand side. And as we go from 1 to 33, what we're seeing is that the proportion of students who answer the question correctly is going down. So we're seeing this slope going down. So it goes from, the scale goes from 90% on the left-hand 90% at the top to 0 at the bottom, and you can see that as we go across we get fewer students being able to answer the questions correctly. And of course as we get towards the end, some students aren't even attempting those questions because they've not got to them, so you'd expect that sort of thing. But superimposed upon that, what we see is this other pattern. And so the red fluency, as we go through from question 1 to 11, what we're seeing is that actually we're doing quite well on that nationally. That from question 1 to 11 we're doing quite well, and then a problem-solving question pops up, and boom, we fall down a little hole. And then we're back to fluency and we recover again, and then we're starting to get more and more problem-solving questions, and it's getting tougher and tougher, and we're doing less and less well, and less and less well. And of course the reason why I picked this one, this Year 7 from last year, is because right at the end there was a question that I considered to be fluency only. Then bam, we're back! And problem-solving, oh no we're not. So by looking even at our assessment of NAPLAN, our NAPLAN questions in this fluency only and fluency plus way, in the industrial to the post-industrial way, What we're seeing is that actually there's lots of room for improvement nationally in our NAPLAN performance, but it's not in fluency. Nationally, we're not going to get improvement through more and more drilling of the kids, through more and more instruction of the kids, because actually we're pretty good on that. The place where we're going to get a really positive improvement is actually down here in our problem solving. And what we've seen is that schools who've focused on the problem solving aspects, what they've got is that their results might be a bit lower than the national average in the fluency part, but in the problem solving part, they're way above the national average. And so their improvement that they've got has been up on this right hand side. And in fact, what you find for some of those schools is that you get along the questions and there's a fluency question and there's a massive dip. The kids have got nothing because somebody needed to tell them that thing and nobody told them. So they had very little to offer. So what they did was, when they got the NAPLAN results, they went back and they had a lesson on it. Now the kids had it and they were all right. You can't do that with problem solving. The problem solving is the long game. Those schools had created problem solvers and had got the improvement because the kids were problem solvers. Because on this right-hand side, their results were higher than the national average. It was also interesting to talk to some of those kids because question 1 was done very poorly in some of those schools. And you talk to the kids and they said, I thought it was a trick. I looked at it and thought, can't be that easy. No. So they actually didn't do very well at question 1 because of that.